Hello and welcome. In this discussion we are going to be discussing about the concurrency control in a database. Concurrency control can be regarded as one of the most important activities or most important controls in a database, right? In fact, it might be termed as a key role in a database because it ensures database security and database consistency, and it helps to minimize data anomalies in the system. And concurrency means, of course, we have discussed before that there are many concurrent users, right? So how in the presence of many concurrent users, let's say 10,000, 50,000 users, you maintain and you ensure that the database is consistent, that is, the data in the database is consistent. So that is partly due to the concurrency control in the database. So in order to study or discuss the concurrency control, the fundamental thing that we discuss should be transaction, right? And what is a transaction? An action or series of actions carried out by a single user or application program which reads or updates the contents of the database. Remember, I talked about an excellent example of a transaction in a banking system. If person A is giving money to person B, the transaction would be that amount given by A would be deducted from person A's account, and the amount that is given to B would be added or credited to person B's account. So transaction would be a logical unit of work in a database. What do we mean by a logical unit of work? Similarly, in this example, unless account A's amount is deducted and account B's amount is incremented or increased, the full transaction does not complete. It is not the case that amount is deducted from person A's account but amount is not added to person B's account. So it's basically a full unit or a logic unit of work on the database. It may be an entire program, a part of a program, or a single command. For example, SQL insert or update, or may involve any number of operations on the database. The key idea is whatever transaction we define, the transaction should occur in full. There is no concept of partial transaction or half transaction. Now, a transaction can have two outcomes or two results. If it completes successfully, the transaction is said to have committed, right? So what do we mean by committed? Committed means that the transaction has completed successfully. In our example of the banking system, if account A has been decreased with 5,000 and account B has increased with 5,000, the transaction has completed successfully or the transaction has committed. So now you can imagine that if account A's amount has been decreased by 5,000 rupees and account B's amount has been increased by 5,000 rupees, the database is now again consistent because account A and account B are both in a new consistent state. On the other hand, if the transaction does not execute successfully, the transaction is aborted, right? So transaction would have only two states. It would either be committed or it would either be aborted. There won't be a concept of partial transaction or partially committed or partially aborted transaction. So what happens if the transaction is aborted? If a transaction is aborted, the database must be restored to the consistent state it was before the transaction started. And we call such a feature rollback or undone. Okay. So in our example of account A and account B, if account A was decreased by rupees 5,000 but the account B was not increased by 5,000, if we roll back the transaction or abort the transaction, what it should do? It should increase the rupees 5,000 in account A's amount, isn't it? So that the state is consistent just before when the transaction started. So this is the concept, a really important concept of commit and rollback. In SQL we have statements, right? We can execute statements in any database, and when we type commit and write semicolon, then of course the results or the statements that we have executed become permanent on the database, right? And we can also write rollback to roll back any undone changes. So this diagram basically shows how the transaction is processed. It's called the state transition diagram for a transaction. So when we begin the transaction is in the active phase, right? And it is in the active phase, then it goes into the partially committed phase, and when we execute commit successfully, it is in the committed state. On the other hand, if the active transaction is aborted, right? So aborted means we move to the failed state and then we move to the aborted state. Now the thing to note is that when we are working on the transaction and the transaction is partially committed, right, there might be a problem over here. So in that case also, when we abort the transaction from here, the state would move from partially committed to failed, and the failed state would finally move on to the aborted state. So all transactions must have the ACID properties, or 4 basic properties. These are called ACID properties. And what do we mean by that? The A is for atomicity, and atomicity is the all or nothing property. Remember my discussion of the banking system. So it is either the full transaction or no transaction. There is no concept of a partial transaction, okay? It cannot be further divided into smaller parts. So it is a logical single unit of work. The second is consistency. A transaction must transform the database from one consistent state to another consistent state. So there should not be a transaction like that leaves the database in an inconsistent state. So you start with a consistent state, and after the transaction you end up again in a consistent state. So it is the responsibility of both the DBMS and application developers to ensure consistency. And we know that we have different kinds of constraints also, right? We can specify the database schema to ensure consistency. The third is isolation. And transactions execute independently of one another, right? So in other words, the partial effects of incomplete transaction should not be visible to other transactions. That is the most important part, right? So if transactions are working independently of one another, if we have basically transaction T1 right, if of course we have the transaction if transaction T1 and transaction T2 are operating, right, and transaction T2 depends on the results of transaction T1, then unless and until the full transaction T1 has completed, then only transaction T2 should have access to the changes created by transaction T1, right? So transaction T1 should have completed and made the database consistent so that transaction T2 can access the data. That is the idea. Then of course we have durability. The effects of successfully completed or committed transactions are permanently recorded in the database and cannot be lost because of subsequent failure. It is the responsibility of the recovery subsystem to ensure durability, right? So once a transaction has committed, right, it has become permanent and it should be saved permanently. There shouldn't be loss of that transaction. And of course backup and recovery systems ensure just that.